Hey everyone, welcome to the Lit in Space podcast. This is Alessio, founder of Kernel Labs, and I'm joined by Swix, founder of Small AI.
Hello, hello. We're delighted to be in the remote studio today with Anish and Raz of Traversal. Welcome.
Thank you for having us.
Yeah, thank you.
Yeah. So Anish, I've met you guys before. You were kind enough to show me a demo of Traversal before your launch, and then you spoke at AIE. Maybe you can kick us off with explaining your backgrounds and how you got into starting Traversal.
Yeah, absolutely. I'll start and I'll let Raz add to it. So my background in the world, I guess, like you, I'm from Singapore. I've been in the US now for 15 years. Most of my time has been in technical institutions. I did my PhD at MIT in computer science about 10 years ago. I just fell in love with AI and ML and wanted to understand it deeply. And most of my research at MIT was in a field called causal machine learning. So the idea that, correlation isn't causation. So how do you get these AI systems to pick up cause and effect relationships from data? And also reinforcement learning, which is, to me, fundamentally about how do you search large spaces effectively. And I loved it. And my goal was to kind of be in AI research for the rest of my life. And I thought the best version of that is to be a professor, and was lucky enough to get into Columbia as faculty. So I'm a professor there of operations research and computer science. But I think with all the developments happening in LLMs and AI agents, as I was making the transition from PhD life to faculty life, it just felt there's so much huge explosion of activity and of research activity in industry, especially in startups with research in their DNA taking on a very technical problem. It felt like a good time to stretch myself in that way. And so that was kind of my philosophical reason for starting Traversal. And then obviously Raz and Raj and Ahmed, who are my other co-founders, they all moved to New York at the same time as me. I've known Raz and Raj for a long time from MIT. And so we just, all saw where the puck was going with AI. So started the company together in Jan of 2024 without really an idea, honestly. We just had an idea. We just basically said we used to come to WeWork every day at 9 a.m. and be like, let's think until something comes to us. And but we're looking for something pretty specific. I think something at the intersection of causal machine learning, reinforcement learning, and how it intersected with AI agents. This is before school, in Jan 2024. Not that many people are talking about it, but we felt like this has to be important because that's how you actuate in the world. And then our fourth co-founder, Ahmed, who is from Citadel Securities, before he was the one who really got us in this problem. I think he had dealt, as you can imagine, uptime is of utmost importance at a place like Citadel. And so troubleshooting and incident response is something they think about a lot. As we looked into it, it kind of felt like a perfect problem for us to take on. And we can get into why, but it felt perfectly at this border of causal ML, reinforcement learning, and LLMs and AI agents. It fit really nicely. So I can talk about why exactly, but I'll let Raz introduce himself.
Hey, I'm Raz. My background is, I grew up in India. My background is also in AI research. I came to US actually exactly 10 years ago on August 14th, 2015. And for my PhD at Berkeley, I started in foundations of machine learning more broadly, but then I made my way towards causal machine learning through a startup in observability for wireless systems. They're trying to do root cause analysis for when Wi-Fi goes down. Is it a device problem? Is it a LAN problem? So that kind of problem during an internship provoked my interest into this field, and I moved in that direction through the rest of my PhD. So we say correlation isn't causation, and I joke, well, when I say it, then I'm allowed to say it because I have a degree. You got to follow it. And then I went to MIT for my postdoc, and I met Anish there, and we had very similar research interests. We vibed together and started dreaming of, how do we convert theorems into companies? But that really took off when I also got a job in New York as a faculty in Cornell Tech, and I was moving. Again, similar department, operational research and computer science. And Anish and I were like, okay, we will be in New York. We have dreamt enough. Maybe it's time to do something about it. And we were like, what do we know? We said, we know AI, we know causal ML. What we don't have is a team, but slowly it glued together, and we don't have a problem. Slowly we figured it out. And here we are. I think it's a very exciting space of a very rich problem. No matter how you look at it, the pain point, the data richness from an AI's perspective, the product experience from a user experience. So it kind of feels like a blessing in disguise that we landed on this problem, although this is not the most natural problem that would have come to, either of us during our research time. So, yeah.
Yeah, tell us more about that. I think this was one of the first almost obvious ideas when AI came out. I think I've seen dozens of AI SRE companies. It was almost kind of like a meme at some point. But then obviously you guys figure something out. So I'm curious how much of it is your unique approach versus timing with the model performance versus, the market being ready. Like maybe talk people through how you went through the idea maze to get there.
Yeah. So funnily enough, I remember when we were flying to San Francisco to pitch, I was on the plane trying to understand what a trace is. I'd never heard the word SRE before. So we really came to this problem from like first principles, having no understanding of any of this. And so I think for the idea maze, we went through a few different ideas of how causal machine learning and LLMs fit together, like what A/B testing for LLMs looks like, what dynamic prompt tuning for LLMs look like. Then we thought about what does something like amplitude look like product analytics for LLMs. So all in this general space of observability, but like hovering around it. And I think it was really when we saw this problem from the world of like core engineering that it kind of clicked. I think specifically because the market is really big, I think. And it's a long-standing problem that it's not like you have to make a bet that LLMs will get bigger or like A/B testing will be important for these systems. This is like a long-standing 30, 40-year-old problem without really a great solution so far. So I think that's really what got us interested. And then I think in terms of the why we felt with a unique edge, because I think at the heart of it, if you just trim it down to the core of it, it's basically if some spike that happens, like latency shoots up or something like that, and you're trying to figure out why, the problem is there's 1,000 other spikes happening at the same time. And so, and you're trying to figure out, is a given spike a symptom of the issue, a spurious correlation because something else is wrong, or truly the root cause, right? And so it's about like finding this needle in a haystack with many fake needles everywhere. And that's exactly what Causal ML and RL do. It's about searching for this haystack and figuring out how to filter these fake needles. And so it fit aesthetically and also in terms of like our technical expertise really well. And I think we looked at the haystack as like logs and metrics and traces and code and config files and, Slack messages. So, and that's exactly what these LLMs are good at understanding. And, it's at any large enterprise, you're dealing with like petabytes of data. It's like a massive search problem. And so you cannot just put all of it into context of an LLM and hope something great happens. You have to search the data sequentially and adaptively, right? And that's what these agentic systems are fundamentally about. And you have to like query autonomously many different systems, whether it's Elastic, Grafana, ServiceNow, Datadog, Elastic. And so in terms of like the generational wave of technology and what we thought we'd be good at, it fit really nicely. And I think that maybe the third thing is that everything we'd seen at that point in the world of like AI SWE, I guess, like all of these AI-powered coding assistants, like that was just starting to pick up. And so it's pretty clear to us that, and we were trying to use it ourselves, and sometimes we didn't understand what the code was doing, but, we shipped it. And so it's like, well, if this is going to happen a lot more. And so if it breaks, no one's going to have any clue as to how it broke or why it broke. And so rather than So we're going to spend all of our time firefighting and being on call and doing QA work, which I think would suck, right? If that's what engineering discipline became. And so we felt like something like Traversal, which is thinking about software maintenance, not software development, has to come about to like fit with that wave. And so that was in the sense of market timing, I guess. Yeah. So that was all the confluence of factors that came that made it work for us. And I mean, obviously, the other thing is that we got funded, so that helped. Right. Right. And I think that the reason that happened was that like our first VC backer was Sequoia, and I think they had met I think like 20 VCs, 20 AI story companies before this, but unbeknownst to us, and that was the first question. Like Bogomil, who's a board member from the asked, is like, I've heard this pitch 20 times before. Why on earth should we go with you? And so we kind of explained, like how we were thinking about it. And I think through that conversation for a few days, it was clear to both of us that this is like really an AI problem, not an observability problem at the heart of it. And so then a team like us who doesn't know anything about observability, but knows a decent amount of AI are the right kind of people to solve it. I'd say that's honestly what last year was about, was just being a research org, trying to figure out how to make this work.
It would be great if we can do maybe a demo in a little bit. So maybe queue that up. But can you talk through just talk about the inputs and then kind of like the runtime of Traversal, so to speak, what it does, and then kind of the output of it. I think today, what I do, for example, is like I have a Sentry MCP server that gets my issues. I put it in Cursor, write a fix, figure out if it works, ship it, hope it fixed it. What's kind of like the future of that with Traversal? Like, what does it look like to be a user?
Yeah, so I think a couple of things. One is I think that works really well, that kind of general flow you have when it's either the problem is really localized, and so the error log you're getting from, say, Sentry is very high signal, and it connects to a small code base nicely. Now, imagine you are a Fortune 50 company. Most of the people who are dealing with these kind of software operations, it's incredibly distributed, right? And building the fragmentation across 50, 100 teams, you cannot do that, essentially. There's just no way. For a variety of reasons, because you have to like be querying over petabytes of data, and it's not like a simple MCP high intent query. Like you have to be searching the space in a much more intelligent way. And you have to build a shared context across all these different systems while respecting rate limits, because any sort of serious observability system will put rate limits on you. And so and typically people want an answer in 2 minutes. Like that's what we've learned from just like working with customers. 2 minutes is kind of the sweet spot. And so how do you search through petabytes of data in 2 minutes with many, many fragmented pieces of systems, right? And so I think that in some ways is just as much an infrastructure problem as an AI problem. And I think if I think about the last 6 months, we've been almost more of an infrastructure company than an AI company, like just figuring out how to search these things effectively, the right way to cache this data, so you can you can search it in real time. So I think that's what the complexity is. I think for like very, very localized things, it's okay. But when you're dealing with like production grade scale, it gets hard quickly.
Yeah, let's jump into a demo. I think that's, most people that listen also run into the same problem. So I think they'll understand it better.
Let me share my screen. So do you see this side screen on the top bottom, right bottom? I can remove.
No, I only see the Traversal demo.
Okay, wonderful. Yeah, so I'll give you basically a rundown of one of the incidents. This is our landing page today, and we keep making it more and more interesting. So there are a few ways people use Traversal today. One is, Traversal auto triggers on alerts in Slack channels or in your Teams channel, wherever.
Maybe Raj, you don't want to talk it through the slide that we usually do?
Okay, 1 second. Give me a second.
Yeah. So, yeah, of course.
So do you see the slide? Yeah, okay. So, so I think there are a few ways Traversal is used today. One is, it auto triggers on alerts. The major way today it's used is when it's in some incident channel. It auto joins when an incident channel is created, and it tries to provide its findings right away in a few minutes after the channel is created. So what you're seeing on the screen is one such instance of, incident was created around 5:55 p.m. And within like 5 to 10 minutes, Traversal was back with a root cause based on a very small description that is usually the part of the ticket that creates the incident. So what you're seeing on the right side is the thread that Traversal creates based on its investigation sifting through live telemetry. In this case, the issue that the users are facing was due to some recent backend code change, and the AI nailed it, pinpointed the change, gave very targeted evidence, and then engineers also like to audit it. So that's what you're seeing as the follow-up interaction on the Traversal finding, is if that's the real root cause or not, and it was the case. So this is the most basic way the Traversal interacts and shows output. What it's doing in the background is it's sifting through massive telemetry data. So in this case, it's around 1,300 microservices that's trying to.
So this demo is basically with DigitalOcean, which is one of our first customers, and it's in production. They're being used by a number of their engineers. And so this was like a live demo. This was like an actual incident that they had, which they're now autonomously using this AI SRE to help them troubleshoot for the past few months. And we're now just going to show you a scale of their system, and then we'll run that specific incident that you saw. We'll just rerun it live with that data that we had access to then.
Yeah. So this is like the scale here is around 1,000 plus microservices. You're talking about billions of logs, and if you look at just 15 minutes, you're seeing millions of logs in certain indices. If you traverse across all their indices, it's way more volume. We're talking about hundreds of millions of time series in certain regions, and they have a few dozens of regions, making it a billion time series scale as well. People often use dashboards to accelerate their debugging, but they have hundreds of dashboards as well. Here, you might say code changes are easy to find, but at enterprise scale, you typically have a few thousand repos, and each repo might have a few thousand PRs and deployments that go out every day. So this is what the AI is trying to query in real time and come back with an answer. And that's what you saw in the Slack channel. So now let me just rerun it and show you how it feels when it's doing its investigation. Do you see my traversal screen now?
We've seen the Riverside thing. Yeah, maybe.
Okay. Wonderful. So you can see that the input to any investigation, you can add a lot of context, but there are two fundamental inputs. One is an approximate guess of when the incident began or it was first noticed. So that was, in this case, evening on April 22nd. And then a brief description of what happened. And you can see it's like something was not working. People couldn't select some region while they were trying to create buckets. You can add more context and use images to kickstart an investigation as well. Is that
And so when people are creating this, are they being notified of the issue somewhere else and then they come to you? Or are you automatically pre-filling this so that they can start the investigation?
So typically, I'd say it auto triggers off an incident channel or an alert channel. And so that's typically the flow that happens. Sometimes people will come to our UI for, well, two reasons. One is if they want to do a deep dive into an investigation, because on Slack, you just get a small piece of information, basically like the leads. If you want to do a deep dive as to why we believe that is the answer, giving all of the associated evidence, doing follow-ups, all that kind of stuff can happen on our UI. The reason people would come to this page is a few reasons. One is sometimes they may not be an incident, but they just kind of want to get a sense of what's going on with their system. So sometimes on, let's say people will go to a like Grafana or Datadog or something, even when something isn't wrong, to just get like a health check of like, is everything okay? Is everything cool? And so people kind of do that too. It's like, oh, this part of my systems feels kind of slow. Can you just figure out what's going on? For this, like this general health check type thing. So I'd say that's a typical use case for coming on the UI and beginning a manual investigation.
Yeah. And then, so the next step is kind of like context creation from an engineering perspective. How do you guys think about building the context? And then maybe if you can talk a bit about long context and whether or not that's something useful to you, or, I think there's always this question of like, if you could put all the data in, would it be better? Like, I think here you have definitely more data than can fit in the context window. So I'm curious, like, where the sweet spot is.
So context. So I think there are a few ways people do add context, which teams, which services, which alerts they are looking at, which dashboards they are looking at. So I think those nuggets are definitely helpful in making the investigation faster. One of the things that we have shied away from is asking too much from the user, because then what is the value add of Traversal, right? That if you have to find all that context and give it to the AI to go do the last mile delivery. So the onus is on us. So let me just run it and show you what is happening. So when the user asks this question, now Traversal is going and figuring out what all context should be pulled in for this particular issue that the user is describing. And in the background, it's leveraging who is asking the question, at what time the question is being asked, and its own understanding of the knowledge base or the system architecture in the background. Based on that, it's making queries to, of course, the live data, the logs, the metrics, the traces, and is building that context and is doing this sequential hopping as it's building this context to hop from service to service, as you can see, from index to index, and finding these three services are impacted. Okay, but they are also connected like this. So let me go hop there. So this kind of context building is being done by AI, and that's why it takes a couple of minutes. But the user can always warm start when they come to the UI or on Slack by sharing that, hey, begin the investigation. Here is the three things I already know. And then it can accelerate the findings of the AI. But so that's how we're thinking about context.
And I'll add that a lot of times the context is implicitly getting built by things like what is growing in the Slack channel, and like the LLM kind of parsing all the relevant nuggets that are getting formed in that war room by itself. And it's using that to guide the search as well, implicitly through the process. But we found that the less you, especially in like a highly stressful time, like an incident, the less you can ask of an on-call engineer, the better in some sense.
Yeah. But to I think your question of how much context is being used by AI to come to the answer, you can see that, it has looked at a few hundreds of millions of logs, tens of thousands of time series, a few hundred pull request deployments, and thousands of dashboards. If you just take the token count of this much data, it's easily few million tokens. But then how do you do the processing of it so that whenever it hits an LLM or a reasoning or an orchestrator agent, the context is maintained? So that goes into the tool orchestration or the tool building and memory management that we do on our end, so that at any given point none of the LLMs or agents are overwhelmed. So that's part of our agentic architecture. That raw context length is few million tokens, which cannot fit in a single LLM, but we still try to manage the right pieces to get to the answer quickly.
Yeah, so right now, if I were one of the VCs that have seen all the pitches, I would be like, well, aren't you just getting all this data and then asking an AI what to do? And I think maybe here is where you start putting some of the causal ML work background that you guys have. So can you maybe now show the forks? So there's kind of like the way that a lot of companies does it, which is like, hey, you build the context. Now you ask the LLM to figure out why this was happening. What are like some of the things that you're doing differently that you can talk about?
So I'll note a few things. I'll let Raz answer. I guess there's building the context itself is where a huge amount of the pain is, right? Because you're dealing with, let's say, petabytes of data, like let's say 1 billion possible symptoms, and you have to get it down to a small number of symptoms. And that it's this like massive data processing pipeline where we're getting more and more relevant context over time. And there's LLMs throughout that process. And each of those LLMs, there's basically AI agents throughout that process helping to winnow down the relevant amount of information. And the way it's winnowing down that information is by running these kinds of statistical tests that we have built in a proprietary way. Because most of the data you're looking at is like time series data. And these LLMs are really bad at processing time series data, right? And that's really where like good statistics comes in. So those are basically like statistical tests or the toolkit that the AI agent has access to. And like almost like a data scientist is deciding, dynamically what is the next best collection of statistical tests to run to filter down the search space. And also use at the same time the semantic information associated with the logs, the metrics, the traces, and so on and so forth. It's like a continuous cutting down of the data. And the way the data is being cut down is by an AI agent system dynamically deciding what statistical test to run at that point in time. And Raz, you want to add to it?
Yeah, I think the question is, you build all this, as Anish said, you have to build this context in an intelligent fashion. You can use LLM for the semantic side of it and statistics for the time series aspects of it. So what we have built is like, semantics meets statistics kind of framework. Let me show you a brief diagram that helps you navigate this huge amount of data. So if you look at this, at a high level, it is a reasoning agent that is trying to sift through your observability stack, and you have so many different kinds of data, and then process them, and then go through, find all the signals in that data. So at any given time, I showed you there are 10 billion time series. Somebody comes and tells me, I am having this particular issues. Which of those time series should I look at? It's unclear, and that reasoning has to be built into the agent. The agent is not good at looking at time series data, so that is what statistics needs to take care of. But statistics doesn't understand what is the relationship between latency and memory usage and disk utilization. So that is the LLM part. So how do we intertwine these various tools to sift through the data and then come up with, sifting through so much data to this one-line root cause candidate that is also grounded in factual symptoms that are being observed in the data, is where, I would say it's not just a simple LLM call or a simple MCP React agent that can do this easily.
Great. So now people come here, and then what's the next step? Are people moving off to then fix the issue? So I know in the screenshot you showed before, you suggested rolling back one of the commits. Are you guys mostly focused on fastest path to just stopping the bleeding, so to speak? Or are you also helping companies think about, long term, this is how you can fix this?
Yeah, it's a good question. I'd say typically when you start with a company, we only ask for read-only access to your system because that's what security is typically comfortable with. And people also really hate it if you tell them that you're going to install like not an AI agent, but like an agent on their infrastructure host, right? Because that's even more of a computational overhead. So what people are generally comfortable with is read-only API access. And you have to kind of build trust there. Once you work with a company for a while, then obviously the next question that comes up is, can you kind of self-heal the system for me? And there's a few different answers to that. One is simple things like pull back this, revert this commit or something like that if it's very localized that way. And the other thing is that a lot of these companies, especially large companies, have these automation scripts to heal their system, and there are like thousands of them. And the problem is they don't know which one to run, like restart this pod, auto scale this particular part of your infrastructure, and so on and so forth. And so they don't know which one to run. And the thing is, if you find the root cause correctly, then these LLMs are actually pretty good semantically understanding what each of these different healing scripts are doing, and it can then kind of connect it or match it to the right one to run. And that's how we've been at least threading the needle of self-healing, because people don't want to give you full write access where you can just do whatever to their system. So it has to be like a whitelisted set of commands. And typically that takes the form of pre-existing scripts that they have found to be helpful.
That makes sense. I have another maybe slightly related question, which is the business model of these things. I think we talked about it on the podcast a little bit, but you had, like I said, I use the Sentry MCP, right? But Sentry has a Sentry Seer product, but I don't pay for it because I use the MCP for free. Do the data sources, like, are they your friends? Like, are they happy that you're building this? Like, does Elastic want to build something here? Like, what are like the competitive dynamics in the market?
Yeah, it's a good question. I think at least what we have seen is that as you start hitting, even mid-size and larger organizations, it's incredibly fragmented. Like they're using like 7 or 8 different tools. They're using, like one company we work with using Datadog, Thousand Eyes, Splunk, Dynatrace, Datadog, ServiceNow. And I think, and if you want to troubleshoot, you have to kind of traverse through all of these different systems, pun intended, right? And so that's really the pain, right? Is the fragmentation of the system and fragmentation of teams. Now, the problem is that all of these different companies, typically the way they work is they price based on the amount of data they're storing, right? And so, they have very little incentive for company A to provide you any insight on data being stored on observability company B, right? Because that just doesn't fit with their pricing model as it stands. And so, but the problem is to troubleshoot well, you have to go talk to both of them in an iterative way almost. And that's why I think there's a chance for a new company such as ourselves to have value, because we're not trying to sell you data storage. We're trying to sell you an outcome, which is like the investigation itself. And we're reasonably indifferent as to where the data is coming from and agnostic, right? And kind of the Switzerland of, we don't really care what the data is. So I'd say that's been at least our perspective on why a company such as ourselves has the right to win, even though, there are these incredible incumbents in the space of observability.
Is this the pitch that you give investors? How did you go into you switching the same thing and you're like, oh, we'll just be the Switzerland, we'll fix it, it's all good. What do you think? I guess like, if you do some self-reflection, it's like, what do you think is really unique about the approach you took that really resonated with people, especially when you don't really have a background that is like in this space? Right. Like, I think like, in a black box, you would imagine, okay, the founder of Traversal is probably somebody who ran DevOps or something at one of these big clouds or something like that.
Yeah, I think it was two things. As Sean said, like fundamentally, this is the space of show, not tell. And I think we just had good references of customers actually using the product at scale and dealing with complex incidents. I think that the long-term technical edge will be when you deal with complex incidents. And I'd say most of the companies that have been in the space, they haven't really put a product out that works and people are using it all the time. And also their use case has typically been like smaller, easy runbook automation for alerts versus like actually dealing with incidents where no one has any answer. And so I think the biggest thing was just showing and having, being able to point to customers that are actually using it. And so I think that's probably the number one thing. And then I think the second part of it is explaining why this is such a hard AI problem, where it's not just like, oh, let's throw a chat GPT wrapper around your telemetry and something magical happens, and why that's not possible. And so I think explaining that really carefully, and we can talk about what those key AI challenges are. So I think it was a mix of those two things, which is the actually having it work. And I don't think we've seen any other company in our space having something actually work at production. And then second, a very clear distillation of the key AI problems, which makes it an AI problem, not an observability problem.
Yeah, I mean, and to be clear, I think when Alessio was asking, like, the pitch, it was just, you have very high profile investors. I got connected to you by Bucky, who was at Kleiner at the time, and I was at Lightspeed. And obviously, it looks like you have Brian as well, who I know from Temporal, in previously at Index Ventures. So basically, like, very, very top tier. I know a little bit about your customer list, which you've talked about at the Duels Fair as well. And so, like, yeah, I mean, it's just a really fascinating go-to-market that you've done. And then obviously that also there's a lot of like the chicken and egg, right? Like you have to build the software in design partnership with all these impressive names, and everyone's trying to do it, and you've somehow figured out how. So that's all we're trying to figure out.
And I mean, I can talk through what some of the hard AI problems are here. I think one is, if you think about AI agent company, like AI agent in some sense is a continuum, not a binary, right? It's like you can be more agentic, at least in my opinion. And that's fundamentally about how much of the workflow is deterministic versus not deterministic. Like at the simplest form, you have, a fully predetermined workflow where in each of those steps, there's some LLM being called, in one of those steps or two of those steps, and people call that an agent as well, right? But that's just really like writing traditional software with a machine learning routine in between. And then you have kind of the full extreme, which is the full control flow is decided by an AI agent, right? And that's really hard to do. And I'd say in our world of troubleshooting, you think about it, that especially with complex incidents, we have 50, 100 engineers on a call trying to figure out what happened. And the reason that's happening is because there is no playbook. And so we're just hoping that we throw more bodies at it. Somehow, some hero engineer will figure out what happened, and then the shared context will somehow crystallize, right? And that's kind of a crazy way of doing things, but that is the best we've done so far because of how complex the problem is. And so I think it's one of those situations where it is one of the most agentic problems, in my opinion, out there, troubleshooting like incidents. And that's why I think it's such a hard problem to take on, and why it's a good AI problem, because you cannot like rely on a run book. And you have to kind of generate a lot of synthetic data. You have to think very carefully about statistics, because these LLMs are really bad about thinking about time series data. So these confluence of these few factors makes it, I think, a problem that's like prime for a team such as ourselves that comes out of left field, not from central casting for DevOps, was well suited to solve it.
And if I may add, I think one other thing is, I think that there is runbooks, right? People talk about, is it just a runbook automation product? That's what happens, for regular alerts. And that's what we call AI automation rather than AI intelligence. And then there is incidents where you're completely in the dark. Some people have some ideas, but then you need a lot of collaboration, coordination, knowledge sharing. So I think for us, when we began, the questions were, we don't understand observability as much. We don't understand these workflows as much. But that also forced us to build in a way that would generalize. Like we couldn't cut corners because ironically, we didn't know what the corners are. So how do you cut them? So I think, so then when what we built runs and it actually finds value, we know that it is not hard coded because we didn't know what to hard code. So that's why, like, there is, of course, accuracy is as a long-term battle in this space because the incidents are getting more and more complex. The scale is getting huge and huge. But when our AI one finds an answer, we know it's a good signal. Like it is not by fluke, because there is no way we would have guessed it otherwise. So I think there was also some aspect of that in the excitement with the results, that they would not have just automated runbooks.
Yeah, awesome. One double click on just like the agentic control flow and and reasoning models. Any commentary on just like what the best models have been so far for you? Do you use any open source models in your stack? Is that useful, or are you just frontier models all the way? And then, like, obviously, if you like GPT-5, we can talk about GPT-5 as well.
So I think we keep trying all the models out there. A few things to note. I think one of the reasons we have tried fine tuning, and that does help in certain use cases. But for some of the enterprise customers, we cannot bring our own model because of all the AI regulations. The industry is still trying to figure out how conservative or liberal they have to be with the AI usage. So we built an architecture where the AI is rip and replace. As long as you tell me which endpoints to hit, we'll be able to point it. So we have typically found that reasoning models are critical for our use case. And actually, it is the use case where reasoning models are a necessity. You are trying to argue across so many symptoms and such a complex architecture of what the root cause is, and a simple, 4.0 and the flagship models would not work. So reasoning works. Now the next question is between Anthropic, the three usual suspects, Anthropic, Gemini, and OpenAI. We have typically found historically that OpenAI was better, the O3 in general, but it was also because it was the most easy to use for us to build on top of, so we kept optimizing for it. So there is also this implicit advantage of if you have a well-supported infrastructure, people can move fast. Lately, we have seen Gemini start doing pretty well as well. But again, it's like the infra support is slightly lagging, so then we tend to default to OpenAI for many use cases. GPT-5 versus not, I think the verdict is still not clear. Like GPT-5 starts thinking when it shouldn't think. So that's like, that has been our feeling, but I would say we are still undecisive about it, and we are running some final tests. And tomorrow we'll make a decision: should we switch to in some places where GPT-5 makes sense? Like we use a collection in many places, but like for the heavy lifting, I will decide tomorrow. So far, we have not seen overwhelming positive signal yet.
Okay. I mean, yeah, it's interesting. First of all, I think that eval on GPT-5, I think OpenAI will be very interested to hear that. They always want to know. I mean, they're going to fix bugs in the router, right? Like, I think this is one of the early days still. I think like for you guys, actually, like, I think there's one of these like more controversial views out there that actually you don't really need reasoning models, especially if you have a pretty deterministic workflow that's like, you're fanning out a lot and you're sort of narrowing it down. It's a pretty constrained domain. You don't have to reason from first principles a lot of the time. You can just kind of like literally spell out the steps to debug. So there's an argument to not use workflows, but not use reasoning models. But it sounds like you're pretty O3 centric.
Yeah, and I think the reason is very simple. No amount of workflows will suffice for a big enterprise. Like you have to link together some of the missing pieces, some of the poorly instrumented data, and that requires world knowledge and a few iteration with the world knowledge. So I think the way we think about O3 versus 4.0, like just for reasoning versus not, is do I take my first thought seriously or do I rethink about it a few times, right? So if you compose 4.0 10 times, maybe you can beat, but then aren't you essentially reinventing O3? So I think that's how we think about it, is that no amount of workflows will ever be sufficient because of the missing pieces in system context and lack of good instrumentation in any real enterprise scale system.
And then coming, yeah. Oh, sorry,
I was just going to say one thing that sometimes people bring up is how the Claude models are much better at tool calling.
Yes.
Has that been your experience too?
Yeah, so I think for some of the agentic part of the stack, we are shifting towards Anthropic because their agentic and the tool calling, especially the unstucking part, when you go down a wrong path and you build context that forces you to keep going down the wrong path. I think unstucking, there is signal that Anthropic and Claude are better. So I would say it's real news from our perspective as well. And like we have seen it even like when you compare, for example, Claude Code versus Cursor. Like we are trying to leverage signals from every use case. So internally in the company, we use Cursor and Claude Code. And you see that there is actually some real news in Claude Code as well. So I agree. Like it's a slightly better right now.
Do you have some sort of like formal eval internally that you run, or is it mostly vibes and then some tests?
So, I mean, when we began, it was vibes, but now we do have, proper benchmarks and very detailed eval pipeline that informs our decision. And that's why I was saying that, if you were to ask me for 5 months ago, is GPT O3 better than O1? I was like, yeah, based on my vibes and a couple of incidents. But for GPT-5, I said the verdict is still pending because we are being more systematic about it. And I think for our problems, if you think about incident RCA, there's a lot of structure in the problem. That it's not only about you go from a symptom to root cause, did you get it right? Yes, that's the gold standard. But how do you leverage, how do you break down this problem and see, are you making partial progress in that direction is important to, help both the eval and the calibration of your architecture and potential fine tuning with synthetic data. I would say investment into eval at an earlier stage is highly recommended for that reason.
Yeah, I would add that in some ways, I find, the best AI companies will always have to be the edge of what the models can do, right? I think you always want to be threading the line. If everything works all the time, then you're not really pushing the limit and you're not innovating, right? So I think you always kind of want to be pushing. And so if you're always pushing, then sometimes your system will work, sometimes it won't work. And so then evaluation, I would say, has become sometimes a big bottleneck. You're spending the most engineering hours just evaluating. And so I think the best companies will be investing a lot of time in really good eval. And I think that's core IP. I tell that to the company all the time. Is like one of the core pieces of the IP of this company is how well we do eval. And so I think that is be true of companies in our space and more broadly as AI agent companies. Yeah, and now that we've seen it, we just hired like probably 4 people from the world of PhDs in Europe. Europe's people love benchmarking, right? And eval, so that's the type of person who we've hired a bunch of now to help build out our eval suite.
And basically, they were like, "What will I do?" And I was like, "Create the benchmark and beat the benchmark." They're like, "Oh, that sounds exciting."
But it's funny. On the more business side instead, O3 is obviously very expensive, right? And you mentioned earlier about outcomes. How do you think about that? We had different, we have Brett Taylor on the podcast talk about outcome, kind of like based, resolution based. Dharmesh Shah from HubSpot also talked about different kind of like, results versus work. How do you guys charge for the product? I'm sure a lot of it in the early stages is like, hey, look, we'll figure it out, but where do you see kind of like the market going? Like, do customers respond more to like base fixed fee that is kind of like tied to amount of work? Do they like the outcome based thing for things like this?
Yeah, it's certainly we're in the phase of we're learning and the market is learning as well. I'd say it's a function of 2 things. One is the size of the search space, which is like what is the fundamental like universe that we have to search through. And the best proxy of that is fundamentally the complexity of your infrastructure, like number of hosts, number of containers, whatever, that kind of thing. And then the second one is the number of investigations you're running. Though I'll say that it's different in customer support versus our world, because there you can actually sell a full outcome, like in a pretty binary sense, like was it done, was it not done? In our world, I'd say the maturity of the technology is such where you can basically give really good leads, right? And so it's not a full outcome where the system is healed every time. And so then I think people have a bit more of an aversion to paying for a purely in terms of outcome based because it's not there yet. So I think as our technology matures, as our market matures, then I think we'll move to more of a full outcome based pricing. But right now it's a mix of the size of your infrastructure and then the number of investigations you're running, maybe leaning more towards size of infrastructure than investigations. But for some of the settings where we are actually now able to do like full end-to-end self-healing, then we are trying to sell the full outcome itself.
How far away do you think we are as we kind of wrap for the self-healing part? Do you think that's like 1 year, 2 years, 3 years, or maybe like what percentage of tasks? Because there's obviously like different difficulties, for like the easier ones, medium ones, hard ones. What are like the timelines in your guys' mind?
Raz, you want to take this?
Yeah, sure. So I would say, I think, as Anish said earlier, agents is a continuum. I think self-healing is also a continuum, right? If you ask people who work in infrastructure, they are like Kubernetes auto-scaling. That's a kind of a self-healing. So that analogy aside, our Traversal is already doing self-healing for a universe of issues where it's reliable to do a good root cause and then do self-healing. So I would say those kind of issues are like, say, they occur 10 to 20% of the time, where end to end, you're free and you can, it's like, think of if an L1 and L2 engineer can just do it, that is kind of where AI is today. Now, then there is this level of 30 to 40% of the incidents or issues where you need to involve, a senior engineer for sanity checking. I think that healing will appear in, 6 months to a year, that we will be comfortably, the technology will be there. Its implementation, the form it takes, will continue to be a collaboration with the enterprise. Now, if you go to the question that you had asked earlier in the podcast of like, how are you thinking about the long-term, reorchestration or re-architecting of the code base? I think we are a tad bit away from that kind of a full agentic system that, just reorganizes the whole code base. I would say, well, AI always keeps surprising you, but at least a couple of years away, if not more, where you can then rely on creating in the code base. And I would say that there is a difference between, code-based debugging and reorchestrating the code, and then it interacting with an external system. that is like, you can build a lot of unit tests and make your code perfect. That's what many good companies already do. But when rubber hits the road, then you start seeing the road bumps that you had never accounted for. So what I'm talking about a couple of years away is the issues where you have to see the real production system play out and run into issues that you cannot forecast just by unit testing. I think the things that can be easily taken care of by unit testing would be taken care of in the next year or two, the bulk of those things. But the more severe ones, I think there is still time.
Okay, I think that's a good overview of where we are. Just to end off, any things you want to get on a soapbox about, any predictions, any rants?
I think in terms of rants, I don't have rants, but I'd say in the space of us and many other spaces, I think more showing, less telling. I feel there's a lot of people saying the same thing. And so I think that,
Okay, I think that would be the title of the episode.
Yeah, so I think that would be good in general. And I think maybe, I don't know I think that one interesting problem is that how do you create benchmarks, right? Because for us, the benchmarks we create are such core IP for us, because that's how we decide how we're doing. And then there's a world in which you want to go make that public, but if you make it public, that's you're also giving away so much of like what is core to you. And so I think that is like a stalemate we find ourselves in our world, and I'm sure it exists in other worlds as well that are adjacent, maybe security or coding. So that's something to think about, I guess, is how do we collectively move everyone at the same time retain core IP, which I said a bit part of it is benchmarking. So
Yeah,
I think
I'm actually curious about that. When your customers are evaluating it, how do you run that? Like, we have a company, Dropzone, that is a AI SOC agent. So they do something similar to you in the security space, though. One idea that I've heard is like, hey, you can create these kind of like simulation environments. We have a company called Various AI that does this for reinforcement learning. But there's also this application of like, you can use the same environment to see how an agent that I would buy from you will behave in it, instead of using it as a data generator. Is this something that like it's been on your mind? Like, is there anybody doing interesting work there? Just like, how do I speed run the POC? Because it's also best for you, right? Like, if you can put the Traversal agent in a simulation and just parallelize all these different tests, that's much better than doing a POC for like a month or 2 months. But it feels like that's not really happening yet.
Yeah, I think the problem is, sometimes we've worked with customers where they say, okay, let's basically do chaos engineering a staging environment, and we'll see how you do, and then based on that we'll decide. And then almost invariably, I promise you will crush it there, and then they'll be like, no, actually they're like, to really know, we have to go in production, and you're like, what the hell, right? So I think that's kind of the issue. And then if you're trying to build a high fidelity enough simulator of your production environment, then it's just a production environment. So then I think that's the problem, I guess, is that we've run into. And so the best thing I think we've found so far is if they give you like 10 historical incidents or something like that from production, and assuming that the data retention of your production telemetry is there, that's probably the best way we've found to speed run it, versus like a low complexity environment and creating synthetic bugs there. Somehow that doesn't have that, you cannot get a big contract done that way, is what we've found.
I'll quickly add, I think in the spirit of, the previous question and this question is like, the reason nobody gets convinced on staging environment is that everybody thinks that their environment is unique, right? Like, it's the most complex thing on earth. So they're like, can your AI actually figure out the complexities of my system? Although there are a lot of similarities across environments, but the belief that mine is unique. So I think unless you hit production and show value there, conviction cannot be built in a demo or a staging environment.
Cool, guys. Thanks for joining us. This was great. Any role that you are hiring for, or any other call to action for people?
Yeah, I think we are certainly hiring aggressively. We're all in person in New York City. So we're building like at least for now, a very much like a New York company. And we're proud of that. So people who either live in New York or want to move to New York and want to work at a cool company in the intersection of AI infrastructure, we're hiring on all fronts. So please do reach out to us.
Cool. Thanks, guys.
Excellent.
Awesome. Thank you.